Solving linear equations. A linear equation is any equation where we have a pronumeral with no power greater than 1. So we have basically the power of our pronumeral must be 1. We do not have any x squared or anything like that, because that would then be a nonlinear equation. We need to be able to solve linear equations, and it's a good idea always to check your answer, since there's absolutely no excuse for getting this wrong. A lot of the working that we've used in earlier years just doesn't cut it anymore. So absolutely no to writing a little -5 on each side here. We need to be doing appropriate working by now. Now, of course, the strategies that we are going to be using are inverse operations, and we're used to recalling that reverse BODMAS. But inverse order of operations. Any equation can be thought of as, I had a number, x, I multiplied it by 4, I added 5, and I got 17. What was the number? And when I make the changes to my original starting point of x, multiply by 4, add 5, I must follow order of operations. To reverse that, we work backwards, we follow inverse order of operations. So, of course, here we need to remove the fact that we added 5, which means we are subtracting 5 from both sides. 4x equals 17 take away 5 is 12. I need to now reverse the fact that both sides have been multiplied by 4 by dividing by 4. X equals 12 divided by 4, which is 3. None of that writing your little steps down in little circles on either side anymore. To check, if you're going to check, which I strongly recommend that you do it somewhere a little bit away from your question and write the fact that you are checking and substitute that back in. 4 times x is 3 plus 5 is 12 plus 5 is 17, and that is correct. So you've just checked that the solution you've got works in your original equation. So we're using inverse operations. Now, it is perfectly acceptable to show more working in here. That is to have a line where you say 4x equals 17 minus 5, and a line here where you say x equals 12 divided by 4. For two-step equations, I am quite okay with this level of working. If you are asked to show working for a one-step equation, I didn't even write one because who wants a one-step equation? If you are asked to show working for, say, x plus 4 equals 10, then to show that you knew what you were doing, you would have to put that line of x equals 10 minus 4, x equals 6. If you are asked to show working for anything more than a one-step, simply having each line of the equation like this is fine. So we're using inverse order of operations. In this case, of course, that is, I had a number, x, I multiplied it by 2, I added 5, and then I multiplied the result by 3 and got 4x. Now, here I've got numbers on both, pronumerals on both sides. If I just had 4, it would be very easy to just divide by 3 on both sides. As I've got 4x, you're probably better off, instead of dividing by 3 on both sides, because you get 4/3 x, better off to expand this. So sometimes you want to expand brackets, sometimes you just want to divide both sides by the number at the front. It does sort of depend on which is going to be most useful for you. My rule of thumb is, if the only confusing thing in the whole thing, only complicated thing is the whole thing is you've got a bracket, then you'll just divide both sides by the number at the front. If you've got anything else going on, fractions, pronumerals on both sides, probably want to expand it out. So 3 times 2, that's 6x plus 15 equals 4x. So a possible strategy that we're using here that's useful is expanding the brackets. And of course, we do need to gather like terms, and a priority in any equation, if you've got pronumerals on both sides, is getting all the pronumerals to one side. My preferred one is usually to choose the pronumeral with the lowest absolute value coefficient, ignoring the positives and negatives, but 4 and 6, I might as well remove the 4, so I'm subtracting 4x from both sides. 2x plus 15 equals, now there's nothing there, so I've got 0. If I'd wanted, I could have subtracted 6x from both sides. I would have been left with negative 6x equals 15. A bit of a toss-up there. So 2x equals negative 15. X equals negative 15 over 2. I would just leave this there. If you get a fraction answer, I would simply leave it as a fraction rather than taking that to x equals negative 7.5. It is a good idea to check. That's going to be a bit of an annoying check to do. 3 outside of 2 times negative 15 on 2 plus 5 equals 4 times negative 15 on 2. Running out of space there, for which I apologise. But it's not as bad as it looks, because of course we can cancel. So this is 3 times 2 cancels, negative 15 plus 5 equals 4 times, so that's going to be 2 times negative 15, so negative 30. And negative 15 plus 5, that's negative 10, so 3 times negative 10 equals negative 30. Yes, we're correct. So it's worthwhile working through a check if you've got time, especially at the end of a test. Reverse order operations, remember we have parentheses, brackets around any sum on top of or underneath a fraction, so of course I need to multiply by 4 first. X plus 3 equals 2 times 4 is 8. Subtract 3 from both sides. X equals 5. Do your check very quickly. 5 plus 3 over 4 is, that's 8 divided by 4 is 2, yes. A point that of course we did up here when I had 6x minus 4x is we are gathering any like terms that are on one side. Last question, we have fractions involved. Now obviously your aim is to get rid of the denominators here. There's a couple of ways of thinking about it. This side, obviously I need to multiply that whole side by 3 to get rid of this divide by 3. I need to multiply the other side here by 2 to get rid of the fact that I've got to divide by 2. If you prefer to think about it as getting this to a common denominator of 6 by multiplying this side by 2 and this side by 3 and then cancelling the denominators out, because once you have a common denominator in an equation you can just cancel, it's really the same process. So multiply both sides by 2. That will give me 2 outside of 4x minus 2 up here. And multiply both sides by 3. So multiplying both sides by 2 cancelled out this 2 here. Multiplying both sides by 3, 3 outside of 3x minus 1, cancelled out this 3 here. So now I've got brackets, expand them both. 8x minus 4 equals 9x minus 3. Rearranging and gathering like terms. So I would probably end up subtracting 8x from both sides. Negative 4 equals x minus 3. Add 3 to both sides. Negative 1 equals x. And if you get to the stage, sorry, that's unclear for some reason. If you get to the stage where you've got your x on the right-hand side, just rearrange. So there are a bunch of useful strategies, and you will probably want to spend some time practicing the fraction questions.